The flying environment is changing. Increasing air traffic with subsequent increasing demands on airspace and route structures have led to a need for changes in traditional aircraft navigation, monitoring, and control systems. These changes are designed to safely accommodate higher air traffic volumes. By reducing en route airplane separation and at the same time provide access to runways and airfields previously unusable due to terrain or infrastructure limitations. Recall that the 737's FMC uses GPS, IRS, and radio position data to continually calculate its own present position. The navigation monitoring and control changes rely on the airplane's FMC's ability to continually calculate its own present position within a specified precision. This precision is expressed as a distance from the airplane's actual position. It is called Required Navigation Performance, or RNP. ICAO defines RNP as a statement of the navigation performance accuracy necessary for operation within a defined airspace. This navigation performance is quantified with two values: a distance in nautical miles and a probability level. The probability level reflects a percentage of the flight time the airplane's calculated present position must lie within the RNP distance from its actual position. This ensures that airplanes with adequate navigation accuracy remain within a defined pathway or containment boundary. This pathway provides safe separation from terrain, other airplanes, and adjacent airspace. The precision of the airplane's onboard navigation systems make this possible. The biggest advantage of the RNP concept is that the navigation accuracy is based on the airplane's system capabilities rather than on specific ground-based navigation aids. RNP-designated airspace requires an airplane's navigation system to be able to calculate its present position within a specified radius RNP distance from the airplane's actual position. At least 95% of the time it is flying in that airspace. For example, if the RNP for a particular airspace is 4 nautical miles, the FMC calculated present position must be within 4 miles of the airplane's actual position at least 95% of the time it is in that airspace. The required navigation performance, RNP, will vary depending on the airspace. It may be 10 nautical miles over some oceanic routes, or as low as 0.1 nautical miles for near Category 1 approaches. RNP was further defined to address potential rare excursions from the desired flight path, which were not specified under the ICAO definition of RNP. The new RNP standard is called RNP RNAV. It specifies the addition of a containment area, defined in the lateral dimension as twice the RNP value, and centered on the airplane's defined flight path instead of the airspace desired path. RNP RNAV specifies the airplane's navigation system must be able to ensure its present position coordinates are within twice the RNP of the airplane's actual present position. 99.999% of the flight time, the airplane is in that airspace. Whatever the airplane's FMC indicated present position is, the actual present position must be within the RNP distance of that FMC position at least 95% of the time. And it must be within the containment area virtually all of the time. This does not guarantee the airplane is on any defined flight path. It is only a statement of required navigational accuracy. RNP is used in conjunction with the flight path defined in the FMC. When the airplane is on the FMC-defined course centerline and within RNP limits, then you know the FMC's calculated present position will be within the RNP limit distance from the actual course centerline at least 95% of the time. And it will be within twice the RNP distance from the course centerline virtually all of the time. RNP RNAV can be used to reduce route separation and improve obstacle clearance limits beyond the capability of the original ICAO RNP concept. You can determine the RNP for a given airspace by referencing the FMC, applicable route charts, or terminal area procedures. Remember that RNP is a measure of how good your navigation system must be. In order for RNP to be useful, you must also know how good your navigation system actually is. You must know your actual navigation performance, or ANP. ANP is a measure of the airplane's navigation system error. It is the FMC's estimate of the current airplane present position uncertainty. For example, an ANP of 0.5 means FMC's calculated present position is within 0.5 nautical miles of its actual present position at least 95% of the time. In this example, the ADI indicates the airplane is on the center line of its FMC-defined route, which means the FMC has placed its current position on the route centerline. If the ANP is 0.5, the actual airplane position will be no further than 0.5 nautical miles from the actual coordinates of the route at least 95% of the time the airplane is in that airspace. The FMC primarily uses GPS to update its present position, but it is capable of using several sources. The more accurate the source, the smaller the ANP value. This means the FMC's position estimate will be closer to its actual position. GPS updating is most accurate, and while it is active, localizing updating is inhibited. Loss of GPS updating will force the FMC to update its position using the navigation radios, which are not as accurate. If radio updating is lost, the FMC will use IRS updating. With each system loss, ANP will gradually increase, meaning the accuracy of the FMC's present position estimate will decrease. If the ANP number becomes too large, the airplane may not be able to navigate within RNP constraints. When ANP exceeds RNP, the flight crew will be alerted. The message Unable Required Navigation Performance RNP will be enunciated on the map display. You can see it is important for you to know what your RNP and ANP are at any given time. How you find this information will be discussed in another section of this lesson.